Welcome to the IoT Unicorn Podcast. This is Pete Bernard from Microsoft. We have a very special guest today. We're going to be talking about long-term technology trends in the IoT space. So let's get started. So today is part 2 of our conversation with Jeff Torrance, VP of IoT at Qualcomm. And we decided to break this one into 2 parts because, first of all, it's running pretty long. The second thing was that we sort of had an interesting break in topics between 5G, which is part 1, and the new stuff we're going to talk about today is around low power wireless, so LPWA and what's happening there, whether it's NB-IoT or Cat-M, et cetera, and so forth. So I think that's a good conversation that we had there, and it's a really fascinating area for IoT that's around low bandwidth, low power cellular connections as opposed to a 5G more kind of high performance, low latency connection. We're going to talk a little about that. We're going to talk about what things look like in 2040, or at least what we're going to be doing between now and then. And we're going to talk a little bit about kind of total cost of ownership and some other things. So a lot of good concepts and a lot of good stuff going on with this recording. So enjoy the conversation. So you mentioned, so I want to kind of shift topics a little bit toward low power LPWA, and because there's sort of 5G and all that super cool stuff, and low power is also very cool. And I know that Qualcomm's innovated a lot in that space. And so how, in certain scenarios like parking meters or other kind of telemetry and other things, you want to be connected and get that data up to the cloud or have some sort of transfer, but you need to do it in a super low power way because these are battery powered sensors or battery powered systems that are out there, and the batteries need to last years. I actually met a company that I think that you work with that had a meter reading solution, and the battery was like a 16-year battery, right? So you'd go out and plop this thing on top of a gas meter and it would read the digits and send the metadata up to the cloud, and the battery would last 16 years. So that's pretty good. But you can only do that with some really advanced tech. So maybe you can spend a little time talking about LPWA and kind of low power wireless access and sort of what Qualcomm is kind of thinking about there.
Yeah, sure. So this sort of whole area of low power, wide area connectivity, I think historically it's been pretty fragmented. There was some, what I think of as sort of non-3GPP efforts to standardize in that space.
Mm-hmm. Yep.
And, at least from my point of view, when you want to build a communications protocol, it's all about scale. And even if it takes a little bit longer to go through a global standardization process, once you get a global standard to solve the problem, you then end up with a critical mass of R&D investment, cost optimization, power optimization, and then, obviously the mobile network operators can provide a global framework for deployment. So, yeah, absolutely. We see within LPWA, the Cat-M and the NB-IoT standards within 3GPP. We have a chipset that supports both of them. Mm-hmm. We also include backwards compatibility to eGPRS, because being able to you want to be able to be connected even when you come out of coverage of the more modern technologies.
Right.
To me, there's sort of you're right around the power, so it's important to architecture design to drive down power. The other thing, this volume cost is extremely important, and it's important to think about total cost of ownership. So what you're trying to do is build a chipset that will be optimal as a radio. But then you remember I talked also about the other pillars of compute and security. You also want those elements included in the chipset, so you have sort of one solution or one piece of silicon that solves all 3 problems. Otherwise, you optimize the radio and forget about the security and compute, and you end up from the total cost of ownership adding even more in. So I think cost, one important point. I said power is very important. So it has to do with how we optimize the silicon design within and comply to the 3GPP standards. And then what's important is to think about the the network protocols. Yeah, so we can get tremendous coverage with EGPRS, the old 2G standard. But the thing is, that's being, already in the United States largely deprecated. Throughout the world will become deprecated. And if someone deploys a product that's going to be, let's say, a parking meter for 10 years, they can't have the modem become inactive.
Obsolete.
Obsolete because the network's been shut off.
Correct.
So it's really bringing those things together into a solution that really matters.
And then, so ultimately the kind of the LPWA standards will become part of the whole 5G story, right? I mean, that'll be part of the 5G infrastructure that's now being rolled out in the future. Will be able to support a lot of these kind of low power scenarios as well.
That's right. And I think, there's an important transition stage. So there's something called dynamic spectrum sharing, DSS, which allows 4G and 5G to coexist, and effectively for a network operator to, have a small sliver of 4G, a small sliver of 5G, and mainly 5G. A small sliver of 5G and a large amount of their spectrum dedicated to 4G, and then dynamically migrate that spectrum, or what we call refarm that spectrum from 4G to 5G. So we expect 4G itself to be around a long time, and then we see the physical layer of the LPWA standard migrating onto the 5G core network over time as well. So fundamentally, the LPWA solutions we are looking at today should have a very long lifetime and see tremendous rollout of volume.
Yeah. In fact, we were, Microsoft's not participating in embedded world, and I don't believe Qualcomm is, but we had planned with you a pretty cool demo in the booths, and it was a beer cart, and it had an LPWA modem in it, and it would communicate the inventory, how many beers were left on the cart, and where the cart was. So if you can kind of visualize that. So I'm not saying we're going to be disrupting the beer cart market anytime soon, but you can imagine lots of things will be instrumented in retail and in other environments in smart cities where a little bit of data means a lot, right?
But I think you're right, and I know in some ways it's a bit of a frivolous example, but if you're the person who wants to buy one of those beers, is it in stock? No, but maybe it can send a message to whoever restocks it. They come and restock it. You get a message to say that it is restocked. It comes to your cell phone. You can go and pick it up straight away. I think, you start to see, as you said, that little bit of data unlocks a tremendous lot of value for customers. By the way, the main spaces we see for LPWA today are tracking. So, the more or less ubiquitous coverage of LPWA in conjunction with low power and location technology owns itself to a very significant tracking opportunity. And then the other one you mentioned was metering, particularly electrical metering. That's moving very rapidly to, from a global point of view, to cellular communication.
Sure. Well, so you can do the beer cart. The question is, can you do the hot dog cart? Because that's really going to be, that's the breakthrough, I think, is the hot dog cart. I don't know how you could do that. Maybe next year. So where is this all heading? I mean, if you kind of forecasted, I don't know if Qualcomm has kind of a vision of 2025 and sort of, after all these release 16, 17 and all these chips ship and everyone's connected, then what happens? Like the edge and the cloud merge together and it's all sort of a utopian, hyperscale universe, or what happens in 2025?
2025 is probably not anything like the end of it, to be honest. We somehow calibrate our 3G to 4G, 4G to 5G on the historic 2 to 3, 3 to 4. And that was really driven by a consumer market.
Right.
What we're going to find is in, logistics, retail, manufacturing. First of all, it's a much, much bigger opportunity. So it's, the end point's greater. The rate of growth will probably be slower in the short term. Yes, as I said to you, I think the 5G smartphone business will be the first wave of growth for 5G, and then this industrial enterprise space will grow behind it. But I think that's probably a 20-year growth curve. Yeah, I don't think that's something that 5 years and done by any means.
Right. Yeah, no, I agree with you. I think it's a very long cycle. And, like you said, the ability for some of these companies, especially companies in a very maybe traditional sector like energy or healthcare or manufacturing or retail, to start getting that kind of crucial pieces of data that can help them really kind of transform and optimize their business. I think we're just at the beginning of that. And even, we'll be at the beginning of that probably in 2025 as well, until, people keep optimizing this stuff and figuring it out. But I think at the end of the day, it all comes back to, things on the edge being connected to the cloud. And obviously, I think Qualcomm's going to be there to be part of that story.
I think probably just something to add on that, on the business case. So what I think will happen is you'll see the early 5G use cases. Let's take energy or resources or retail or logistics, and somebody will deploy some 5G infrastructure. In the sort of the macro sense, it's almost inevitably the MVNO. In the micro sense, maybe it's the MVNO or it's a private network, and there will be one or two use cases that exploit or make use of that 5G infrastructure. What I think will rapidly happen after that is people will see that the marginal investment to address more business cases will be small, whereas the return will be very significant. Mm-hmm. So what I think will happen is we will see the early networks in industrial enterprise choosing one or two use cases, and then we will see a rapid acceleration, and it will be an ever steepening curve. And I truly believe that's a 20-year project, because the number of things, once you realize, it's a little like the internet. At the outset, from a visionary point of view, you could see the internet was going to, change the way that we do business and the way recreation happened, and television was, sent to the home. Yeah, there were many things you could foresee, but in the details, I don't think people had any idea there was going to be a Facebook or a, or similar. Yeah, I mean, it was Uber. And so I think what's going to happen is the specific use cases we're going to see in this, the specific use cases we're going to see 5G deployed for are just unforeseeable at the moment, and there's just going to be a plethora of them coming.
Yeah, no, and that's exciting, and that's going to be opportunity for a lot of creative people to do something there. So that's good. We just need to make sure we have the right platforms and right standards and the right silicon and everything else, so that people can take these great ideas and make them happen. So that's good. So Jeff, any last thoughts or kind of words of wisdom that you would like to communicate to this massive podcast audience that we have here?
Well, I think I would just say, I truly believe there's going to be a lot of value unlocked from 5G and from 5G enabling digital twins. And those digital twins, whether it's retail, logistics, manufacturing, mining, is going to allow people to have more efficient, more secure, safer existences. And we probably do have a 20-year growth for that on 5G networks. It's a very exciting time to be in.
Okay. Well, we'll have to get back together in 2040 and see how we did. I don't know if you and I will still be doing this stuff, but that's all right. Cool. Well, it's been great talking to you, Jeff, as usual, and really appreciate the time.
Well, thank you, Pete. It's a pleasure, and good luck with your podcasts.
Thank you very much. All right. Take care. This is Pete Bernard. You've been listening to the IoT Unicorn. Thanks for joining us. Stay tuned for the next pod.